Hello friends, welcome back to the bench. Our patient today is an ATX power supply. This is Gigabyte P650G. Now, why do we have it on the bench? I suspect that the power supply in this computer, the computer I'm using to record right now, is experiencing issues. It probably needs to be replaced, and it's 500 watts. This one is 650, so a lot more adequate for my rig. I'm pretty sure it's actually the issues I'm having is a result of a bad HDMI cable, but that's a pretty long cable, so it'll take me a second to find the replacement. But I figured, well, let's get the replacement power supply just in case. However, I figured I'm not gonna buy a new one or working one because they're too expensive. So I figured I'll buy the broken one. So let's see what it does. Nothing. Completely dead, meaning there's no beep and there's no jitter from the fan. It's completely dead. If it's completely dead, then probably we're facing a blown fuse, and the fuse will be blown because of shorted transistor. That is usually what happens, but we'll see. It's actually pretty clean for a power supply. It's really clean. There's silicone here and there. Let's see. We have interesting. So what I'm looking for is a PFC circuit. And I'm not sure whether there is one. Maybe not. Maybe no PFC, which would be good, because that's just added complexity. Okay, so the fuse is indeed blown. That's why we don't have any reaction from it. No signs of caps charging, no sign of anything. But why did the fuse blow? So first let's check here. Huh, interesting. There are no shorts on the primary side. Let's check the secondary. Yeah, not so good. Oh, it takes a... Oh. is this short? No, these are... Oh, all the wires are black. God. Why would you do that? Why would you do that? No, this is fine. This is fine. That's the ground. And that is the ground. Okay, so no shorts. That is kind of unusual. Why would the fuse blow without shorts? Perhaps too much load on it. A voltage drop and overcompensation. Let's see, it says over here T T15. I don't know how to read this, but let's just try to extract this fuse from here. Yeah, so the fuse is definitely blown, but you know how sometimes some people say, like, yeah, it's broken, but it's probably easy to fix, maybe we just need to replace the fuse. And I always say, if the fuse is blown, there's gotta be a reason why it blew. So if you just replace the fuse, you didn't fix anything. What caused the fuse to blow? So here we have such situation where fuse is blown and I can't find any evidence why it blew. So would it be the dry caps? Possibly. Possibly, because if your caps lose capacitance, it makes absolute sense that the current draw could be abnormal. At least momentary current boosts could be way abnormal, which might cause the fuse to blow. But it's rather unusual, especially on this design. It's relatively simple. I don't think, because we have two transistors over here, and that is likely the diode. But hang on, diode should be on the output. There are two of them over here. Let's check here. Yeah, because that's the double diode. Yeah, it beeps for a long time when you apply the leads, because we're dealing with high capacitance. So don't get fooled, like it only touch it and oh, there's a short. Now let's hold it for a little longer, let the caps charge, and then make decisions or determinations. So this is officially a weird case. And I know capacitance is gonna be there on the output, and actually this meter is not gonna tell us much. And the reason I know is because I hear how the meter is reacting. it's taken a while to charge. So we've got capacitance on the output. Oh. This meter might not show us exactly. Yeah, it's showing open, but it's showing open because it's over. Actually, in this case, OL doesn't mean open line. In this case, it means overload or over limit. The capacitance is just too high to measure it. So I wouldn't expect dry caps. We can recap it just to be sure. Nothing wrong with that. It's always good to recap these devices for sure. But why would the fuse blow? That is our main question. Well, let's just replace the fuse and test it. See what it does. If the fuse is gonna blow again, that's gonna be interesting repair. If the fuse blows again. Yeah, well, let's hope it won't. But still, I'm kind of worried. So if I if I plug it in and it does work, and I put some load on it and it still works, that means we have no idea why the fuse blew, and that is slightly concerning. Alrighty, I recorded second video and I forgot to turn on my microphone, so we're gonna have to do it slightly again. So the fuse that was blown, it was 12 amps. I replaced it with 10 amp fuse because I didn't have 12 amp. After which the CPU, the PSU kind of started. I'm saying kinda because it kind of varied. I'm not clear on, I'm pretty sure there's no PFC because the input voltage is too low for PFC to be there. But there are 3 transistors or whatever on the main heatsink, which normally there should be 1 or 2. If there's more, that usually means there's a PFC circuit. But here I don't really see it. But that's besides the point. When I turned it on, it complained about 12 volts V2, which it does not now. Right, we have all the voltages working correctly. And so why did the fuse blow? I have no idea. Not a clue. Second, when I connected the CPU connector for our 12 volts V2, the PSU would turn off. So that usually means that it's a problem with capacitors. Usually. So, to give it to get our confirmation whether it works or it doesn't, we're gonna put some load on it and see if it survives. Moment of truth. It will likely just turn off. The light bulb went on. I have some cold solders over here, so my light bulb doesn't go off. Oh, and it's warming up slightly. We are limited in power. Oh, it completely, yeah, it's blinking here. But that also means Yeah, now it says PG went up after 310 milliseconds. That's correct, because we had lack of power. Let's try it again. 350 milliseconds for PG. That's a bit long. I say it's too long. Let's try that again. $350. Well, at least it's stable. All the voltages look good. Now you see the light bulb, right? When I turn it on, it goes completely lit up, right? As it's kind of charging. And now it's just kind of dim. You can tell that the power is going through it. Now we have 360 milliseconds for PG. So overall, it's low, or it's slow. But in that case, let's connect the cable without the light bulb. Since we know we don't have any shorts. Because the presence of light bulb, especially since I don't remember whether it's 40 watts or 60 watts, either case it's a little low. It restricts the power going to the PSU. So let's just see what it does with no restriction. Now we at least know that it doesn't blow, and if it does, we have 10 amp fuse on it as well. Yeah, 260. So it was the light bulb that was messing this up. Now let's try the load again. And the voltages did not drop. We're getting proper heat from the resistors. Yep. There are no sounds coming from the PSU. Okay, this is now properly roasted. So it works. Yeah, even the cables got hot. Well, not hot, but warm. So it's delivering power. While it delivers power, I don't register any voltage drop, any abnormal voltage drop. All voltages are pretty much perfect. This is one of the best voltages I've seen on the PSU that I repair. Normally I settle even for lower than that. But now, what is the diagnosis? What was wrong? Why did the fuse blow? So obviously, potential reason number one is just plain and simple faulty fuse. Right? That would be option number one. Option number two. Was the fuse too small? Like the PSU just needed more power than the fuse could handle? Unlikely. So you see, when I connected through the light bulb, that first 1-2 seconds, the light bulb goes completely on, so it's pushing the maximum power it can, and it tries to charge, right? Then after it starts working, it stabilizes, it charges all the capacitors on the output, then the level drops down and the light bulb dims, right? So that means the capacitance on the output is good enough. I mean, ESR could be an issue here. If the cabs have high ESR, that would explain. What would that explain? Would that explain blown fuse? It could. It could explain that. So I think what we should do over here is recap this baby. But recapping will be quite a endeavor here because we're very cluttered here, and we have some silicone on these and all that fun stuff. We also have polymer cabs on the outputs. So this is one of those interesting designs that personally I like. The majority of the voltages being created by the PSU, or pretty much all of them, are created on the separate board that is installed like this, right? And we can just remove this board, and on that board we have our well, transistors, diodes, capacitors, coils, that kind of stuff, right? Oh, why did it get so warm? Yeah, there's got to be a PFC over here. That's why it delays. I think I can see a standby transformer over there. Why is it so warm? Well, I did connect the dummy load. I don't remember how much is here, but roughly around 40 watts, maybe 50 watts. Oh, they're still hot. Very hot. So maybe that's why. But that's like very negligible load. I wouldn't expect it to actually cause this much heating. I mean, it's not super hot, it's just warmer than I expected. Oh, it's the transformer that warmed up. Well, transformer will be warming up because that's what actually pushes the power from primary side to secondary side, right? So all that energy needs to pass through the transformer. But if the transformer heats up abnormally, and in this case I wouldn't say it's necessarily abnormal heating, but it's significant heating, that would mean that the transformer is faulty, meaning its attributes, its parameters are different than designed. The board still makes, peace with it, and it still gets the job done because we have relatively well-designed feedback, right? So even on faulty transformer, it's still going to be able to stabilize voltages and just kind of account for that. But that means that if that is the case, the faulty transformer, that means that energy is dissipating on the transformer itself, which means that faulty transformer definitely would explain why the fuse gave out. It would definitely explain that. So let's do this. Let's connect dummy load, but not this, because this is just for a few seconds of testing. We need a 12-volt load that we can connect for a few minutes and see what's heating up. Okay, so PSU has been powering these two drives, the big one and the small one, for for about 10 minutes now, maybe. All voltages are stable and within the range. Our PG was at 240 milliseconds. Very nice. The only thing that I see over here that is heating up to 73 degrees now are what I assume the output diodes. So this board over here, right past the transformer, that's our first stage. That's where we smooth the voltage and pass it over to stabilizers. By stabilizers, I mean we have coils, right, with core, probably ferrite, maybe steel, and capacitors to smooth it out. So those diodes, naturally, they always experience a lot of power dissipation. But when the transformer is faulty, when there's something wrong with the transformer, right, you would expect the diodes to start heating up significantly. 74 degrees, that's a little high for my taste, especially since we're powering up only two hard drives, big one and small one. They don't consume that much energy, but these are actual disks, right? So there's a mother in there and the actual disks that store data. So it's definitely more of a load than SSD, but still we're not talking about, it's not a GPU. GPU, that's a big load, especially, powerful GPU. Powerful CPU, So right now, it doesn't really, the load that it's experiencing is next to nothing. Yet, our diode is at 76, 77 degrees. That seems very high, considering this load. There's some stuff heating up to 60 over here. That also looks like diodes. We have some resistors that are heating up. Also to around 50, but that's okay. Like anything up to 60, that's perfectly fine. Above 70, it's a bit on the higher side. I mean, the semiconductors can operate at the temperatures of 72, 76. This is considered relatively normal temperature, operational temperature. The majority of parameters that you get from the data sheet are expressed for the semiconductor being in the temperature of around 70 degrees. So that's perfectly natural. And now at 10 degrees, it's fine. But here we have almost, what was it? Let me see again. 78, 79, almost 80. So that's not alarming yet. But considering that we have relatively small load on it, it is slightly concerning. Well, no way around it. What we have to do is just keep it running for a little while and see if it blows. I will recap it. Before I use it for anything, I will recap it. But to recap it, it's going to take me a little while, and I'm waiting for the desoldering gun. So I don't want to do it with my solder sucker, which is actually, it's a lot better than those crappy ones. And those ones, right? This one's a lot better, but it's still on the same shelf as this one. It's a lot better, but the same shelf. So we'll see how the desoldering gun is gonna speed up all these desoldering jobs. But that's pretty much it. That is pretty much it. At the moment, the diagnosis is that the fuse opened for unspecified reason, for unknown reason. This is not the first that I get, the first PSU that I get, which seems to only suffer from open fuse, but it is very rare. I can't really remember last time I had a PSU that only had a blown fuse and nothing else wrong with it, because usually that doesn't happen. I had one, actually, now thinking about it, I do remember one which had a blown fuse, and I did replace the fuse, and it worked. But then when I put the load on it, the transformer started giving like horrible sounds. It sounded like it was dying. So there was definitely something wrong with the transformer. In this case, the transformer, even at heavy load, it doesn't seem to generate any sounds. So maybe it's fine, but there must be a reason why that fuse opened. We just can't find that reason right now, but there's gotta be a reason. The fuses don't just blow up by themselves for no reason. I mean, I guess you could argue that perhaps the fuse was faulty, maybe overheated, maybe just plainly faulty, bad batch, faulty batch. That is possible, but that's kind of too easy solution. You know what I mean? It's just kind of lazy to conclude the faulty fuse, because it's very unlikely. It's very unusual. But at the moment, that is our initial diagnosis. The PSU works perfectly fine. All voltages are stable and within the specs, very nicely within the specs. No negotiation. Everything seems to work fine, so that's our repair. Sometimes it's just a fuse. Very unusual, but sometimes it's just a fuse. I did not think this would be this easy. I was expecting shorted transistor, shorted diode, other kind of faults, obviously bad caps, but I don't see anything wrong here. So we're gonna call it a fix, and I will replace my 500 watt PSU that is currently in my rig. I replace it with this one, and we'll see what happens. I'll keep you guys posted. Thank you guys very much for watching. I appreciate you, and I shall see you in the next one.